Alright, so welcome to what is going to be the first of a set of videos in relation to non-right angled trig. So this is trigonometry that we're going to use in regards to triangles that don't have a right angle in them. The first one here would be the sine rule, okay, and what we're essentially trying to do here with the sine rule is figure out either the side of a triangle or an angle of a triangle with some given information in a non-right angled setting. First off, I sort of want to show how we actually approach this rule. Okay, so what we're going to do today is we're going to use a proof style just to see where this rule actually comes from, just so you don't think that I'm plucking it out of thin air. So first thing, in this particular triangle here, we have triangle A, B, C. Okay, the capital A, B, and C are all angles, and the lowercase a, b, and c are all sides. Now, if you cast your mind back to when we were using some non-right angled trig, with some right angled trig, I apologise, with SOHCAHTOA, okay, you remember that we could use these trigonometric ratios to find out sides and angles in triangles, right? So, why don't I actually add in a right angled triangle into this particular triangle? Now, please excuse my art, it's not the best, but you can get the idea of what I'm doing. So now what I've done is I've broken down the triangle into two separate right angled triangles that we can use now. Now we can start to begin the proof. What I'm going to do is I'm going to label this H. That is the height of my triangle. To prove this result up here, we know that we need a sine A. So why don't I drag these two triangles out to be a little bit separate? Okay, I'll move this up so we can see. So from our original diagram, we're working here, we have H, we have B, and we have A. Okay, from SOHCAHTOA, we have an opposite and a hypotenuse side, right? So we're going to be using sine in this particular case. Alright, so we end up with sine A is equal to the opposite, H, over the hypotenuse, which is B. Alright, we want to end up with an expression here of H equaling something. The easiest way to do this is to multiply both sides by B to get rid of the B here, okay, and we're just left with H. So now we have the expression of H is equal to B sine A. Similarly, what we're going to do now, okay, is we are going to come across here and we are going to use the other triangle that we created from our diagram. Okay? So just like that, it also has a height of H, a hypotenuse of A, but this time we're talking about B. Again, if we come back up here to our formula, we're looking for sine of the big angle B, right? So if we take this idea of having sine of B in this particular triangle, you notice H is opposite over the hypotenuse, which in this particular case is A. What we're essentially aiming to do here is we're trying to again get an expression of just H equals something, right? To do that we need to get H by itself, which means we multiply both sides by A, right? These two will cancel, leaving us with now H is equal to A sine B. So now we have two equations here. We have equation 1 and we have equation 2. Both of them, you'll notice, are equal to H. And if they are both equal to the same thing, right, we are able to let them equal each other. So now we have A sine B is equal to B sine A. Now we've established that. That's just by letting this equation equal to this one. Okay, we are able to do that. Now what we want to do, now that we have this equation, is we want to try and get it in the form of A over sine A is equal to B over sine B. What essentially we are trying to do here is divide both sides by sine A. We want that sine A to be on the bottom, correct? Sine A. Okay, so essentially what happens on the right hand side here, you'll notice that these will cancel. This is equal to A over sine A times sine B, and I'm going to write that deliberately, is equal to B. Now, the same thing, we want to end up at the moment with a sine B on the bottom here. So what we're aiming to do here is to divide both sides by sine b. Okay, now there is a reason why I'm going to write it this way. Unfortunately, we're getting a little bit cramped. I'll add some paper in a moment. Okay, I'm going to divide the left-hand side by sine b as well. Because I've divided the left-hand side by sine b and we're multiplying by sine b, they will cancel. Okay, leaving us with just a over sine a is equal to b over sine b. As a result, we've actually proven the sine rule. Okay, it's as easy as that. I hope that helps you in understanding where the sine rule comes from. So this was non-right angle trig. We used some right angle trig to help us establish the rules. Thank you.